Hey, what's up guys? My name is The Cherno and welcome back to my C++ series. Today, just coming at you with a quick video and we're going to talk about what static means in C++. So the static keyword in C++ actually has two meanings depending on what the context is. One of those applies to when you use the static keyword outside of a class or a struct, and the other is when you use static inside a class or struct. Basically, just to cut to the chase, static outside of a class means that the linkage of that symbol that you declare to be static is going to be internal, meaning it's only going to be visible to that translation unit that you've defined it in. Whereas a static variable inside a class or a struct means that that variable is actually going to share memory with all of the instances of the class, meaning that basically across all instances that you create of that class or struct, there's only going to be one instance of that static variable. And a similar thing applies to static methods in a class. There is no instance of that class.
It feels like everywhere I have a type variable in Python, let's say x, and you set it to a value of, say, the number 5, that variable x happens to store an integer type. But at any point in the program, we can change the type that x stores, right? We could change it to, say, the string 5. Many scripting languages tend to be dynamically typed, right? Languages like Python, JavaScript, Ruby, and PHP. And the reason is when we don't have to specify types as we're writing our code, we're able to write the code a little more quickly. Now let's take a look at how Go, a statically typed language, approaches this same problem. So in Go, we might write something like var for variable, x is an integer, we set it equal to 5. So this is a little more verbose, but we're being explicit and we're saying this variable x is an integer. Now, what happens if later in our program we type x equals the string 5? Well, what happens is our program completely breaks. Go as a language, or TypeScript or C++ or one of these statically typed languages, does not allow us to change the type of a variable. Once the type has been set, we need to keep the values stored within that variable of that same type. So the question is, which approach is better? Well, if you had asked me 10 years ago, I may have said that there is a trade-off here, maybe a fairly balanced trade-off, and that the languages like Python, JavaScript, Ruby, and PHP, they chose this way of doing things because it's syntactically simpler, right? We don't have to type nearly as much to get our program up and running. Seems to be a huge advantage, right? We can move faster, we can write code faster. When you're working on larger systems, though, the advice has always been static typing is better. And the reason being, it results in fewer bugs. There's basically never a case where you want to take a variable, say player name, and change it from, say, a string to an integer. That doesn't make sense. You would just create a new variable. So by having a set of tooling that doesn't allow you to accidentally change your types tends to result in less bugs and more readable code. So the trade-off seems to be with dynamic typing, we get to kind of write less code to do the same amount of work, but that code can be more buggy and harder to read, harder to maintain. Or we can write statically typed code, which is less prone to bugs, but takes a little longer to write. These days, I'd argue that static typing is simply better. And that's because newer languages like TypeScript and Go and Rust, they have a thing called type inference. And type inference basically gives us the best of both worlds. It allows us to have static typing, but with a very simple syntax. So for example, in Go, rather than using this verbose syntax here, I could just write x equals 5. And by doing that, the computer knows that x is an integer. It can infer x. C, C++. They didn't have type inference back in the day, and so this trade-off really did exist, right? But these days we can have the best of both worlds with type inference. So you might be wondering, if static typing is so great, why do you teach Python on boot.dev, right? Why don't you just teach the static languages if they're so much better? Even though Python is dynamically typed, it's still an amazing language. I love star programming concepts. It's out of
कोडिंग इंटरव्यूज के अंदर हमसे पूछा जा सकता है कि जिस लैंग्वेज के अंदर हम कोड कर रहे हैं क्या वो स्टैटिकली टाइप्ड है या वो डायनेमिकली टाइप्ड है। इसके आंसर के लिए हमें दोनों टाइप्स को समझना पड़ेगा। स्टैटिकली टाइप्ड लैंग्वेजेस वो होती हैं जिसमें टाइप चेकिंग हमारी कंपाइल टाइम पर ही हो जाती है। फॉर एग्जांपल जावा, C++, ये सारी स्टैटिकली टाइप्ड लैंग्वेजेस हैं। इसके एग्जांपल में अगर हम ये जावा का सैंपल कोड देखें तो इसमें हमने एक इंटीजर नंबर को डिफाइन किया है। उसके बाद हम अपने नंबर के अंदर एक बूलियन वैल्यू को ऐड करने की कोशिश कर रहे हैं, विच इज नॉट अलाउड इन जावा। इसीलिए यहीं पर हमारे पास कंपाइलेशन एरर आ जाएगा कि प्लस ऑपरेटर को हम इंटीजर एंड बूलियन वैल्यूज को ऐड करने के लिए यूज नहीं कर सकते। तो ये हो गई एक स्टैटिकली टाइप्ड लैंग्वेज। वहीं दूसरी तरफ हमारे पास डायनेमिकली टाइप्ड लैंग्वेजेस होती हैं जिनमें टाइप चेकिंग रन टाइम पर हो रही होती है। फॉर एग्जाम्पल इफ वी लुक एट दिस पाइथन कोड, तो यहाँ पर हमने एक नंबर डिफाइन किया है, उसके बाद नंबर के अंदर हम एक स्ट्रिंग को ऐड करने की कोशिश कर रहे हैं जो पाइथन के अंदर अलाउड नहीं होता। पर यहाँ पर कोड लिखते टाइम हमारे पास कोई एरर नहीं आएगा। फाइनली जब हम कोड को एग्जीक्यूट करेंगे तब हमारे पास एरर आएगा कि प्लस ऑपरेटर को हम इंट एंड स्ट्रिंग को ऐड करने के लिए यूज नहीं कर सकते। एंड यू कैन लुक एट दिस चार्ट व्हिच विल हेल्प यू रिमेंबर व्हिच लैंग्वेजेस आर स्टैटिकली टाइप्ड एंड व्हिच आर डायनेमिक। कोडिंग इंटरव्यूज के अंदर हमसे पूछा जा सकता है कि जिस लैंग्वेज के अंदर हम कोड कर रहे हैं
Hello, this is Bradley Needham. I'm going to be talking about runtime type information, or RTTI, in C++ of an object at runtime so that I can do some special processing on it. First, I'm going to create a simple inheritance hierarchy of polymorphic types. In this example, I'll use a shape class. Shape is going to provide a virtual method draw. And I may have a class rectangle that inherits from shape and overrides the draw method and provides an implementation. I may also have another class, ellipse, which also inherits from shape and also overrides the draw method and provides an implementation. Now I'm going to create a couple of helper functions basically to generate random shapes for me, but you can think about this as a function where you're getting this collection of random shapes from a framework or from another part of the program that you don't have control over. Okay, so this function simply returns either a rectangle or an ellipse, and then I might have another function which has selected all.
Hi, I am Devendra Narade. In this video, I am going to cover implementation of runtime type information. RTTI is used to get type information about an object at runtime using pointer or references. Compiler writes code for RTTI with the help of virtual functions and virtual table. When we create an object of a class, first 4 bytes will be a virtual pointer which points to the virtual table, and the first 4 bytes of the virtual table is related to RTTI. There are two main applications of RTTI, type ID and dynamic cast. We are going to cover both of them one by one. The implementation of RTTI is specific to compiler writer. C++ provides a way to get type information of a class at runtime using type ID operator. We can use type ID operator as many times as we want in our program, but it will point to only one type info structure which is unique to the class. Conceptually, when we create an object of class A, compiler adds RTTI information to the class's object, and we can get this information using the type ID operator. Just like an example how RTTI uses type information stored in objects by the compiler to determine at runtime the actual type of an object pointed or referred to. In order to demonstrate it, I am going to use this class relationship where class C is derived from class A and class B. In order to use RTTI, your inheritance graph should be polymorphic, which means you should at least have one virtual function in your base class. In this class A, I have two virtual functions foo1 and foo2 with data member A. In class B, I have class C is publicly derived from class A and B virtual table corresponding to their class. Virtual function table is a table of function pointers pointing to the definitions of virtual functions. When we create an object of class A, the first 4 bytes of that object will point to a virtual table. This bit is called virtual pointer. In this virtual table, second entry is an address to first virtual function foo1, and the third entry is an address to virtual function foo2. Similarly, when we create an object of class B, its object's first 4 bytes will point to B